In this video, we are going to design an ideal high-pass filter with the magnitude response of HD of e power j omega is equal to 1 for pi by 4 to omega pi, and for 0 for modulus of omega is less than or equal to pi by 4. Okay, so here we have to find the values of h of n for n is equal to 11. So if there is an value sequence they have given as the n is equal to 11 or something, they are defining it as finite. So we are going to find the values of h of n, filter coefficient for the finite filter. Okay, and we also find the h of z. So first thing we have to do is first draw an ideal frequency response graph. So frequency response graph, that is with w and h of e power j omega. So it is 1 for pi by 4 to pi. So somewhere pi by 4 to pi, it is 1. So if they are given with an ideal high pass filter with pi by 4 to 5, it is automatically replicates the symmetric also, that is a mirror image also, that is we have to take in. So minus pi to minus pi by 4, this one also we have to take. Okay, so since they have given from pi by 4 to pi, it is 1, or mirror image also we have to take, that is 0 to pi by 4, it is the value, it is 0. So in between these values they have given it as modulus, right? So in between these values, for minus pi for omega from 0 to minus pi less than pi by 4, 0, and minus pi it is also 0. So that only we have drawn the mirror image also with a magnitude value of 1. Second thing, step number 1, you have to find the value of hd of n, that is the desired filter's coefficient value, which is given by 1 by 2 pi integral of minus pi to pi hd of e power j omega into e power j omega n into d omega. Okay, so this limit also varies from minus pi by 2 plus pi, so it also says it is a finite one, so which is equal to 1 by 2 pi integral of, you have to take minus pi to plus pi by 4, minus pi to plus minus pi by 4 e power j omega n, hd of e power j omega, the value it is 1, so it is 1, here it is, into d omega plus here pi by 4 to pi, so pi by 4 to pi, here also e power j omega n, here hd of e power j omega value it is 1, so it is 1 into d omega. Okay, so next, so on integration you have integration of a to b e power of something what to say, z into x is into dx is equal to e power of zx with x varies from a to b divided by the coefficient value z, right? So in this way we have to solve. So 1 by 2 pi into e power j omega n, e power j omega n into d omega. Yes, so we are solving this, so there is no d omega here. For omega values from minus pi to minus pi by 4, with the e power omega we have to substitute from minus pi by 2 plus pi by 4. So integral of z power zx is equal to e power zx divided by z. So here instead of term z, the constant n and j are there, so put n and j here, plus e power j omega n, same with the limits pi by 4 to pi. So here also j omega n, that's why I have taken it as a common one. Yeah, 1 by 2 pi j omega n Next we have to solve this. E power j minus pi by 4 n upper limit minus lower limit pi n plus e power j omega upper limit pi n minus lower limit e power j pi by 4 n. Okay, so then 1 divided by 2 pi n 2 pi j n into, we have these terms as common, and this one and this one. So take these terms, e power j pi n minus e power minus j pi n plus, so here take this minus as common here. So you have this minus, so e power plus j pi by 4n. Here we have taken minus as common, so it will become minus here, e power minus j pi by 4n. So what we have, if we have the formula, right, e power I theta plus e power minus I theta is equal to sin theta. We have the formula. So in the same way we have to proceed. So is it 1 by 2 pi jn into e power j pi by n minus e power minus j pi n. Here if it is plus, it is cos theta. If it is minus, it is sin theta. So here it is minus, so it is sin of pi n minus here sin pi by 4 n. Okay, so this is the value of hd of n. This is the first step. Second step, sometimes they will be asking you to find the h of n values using some windowing techniques. So I'm here using a Hanning window. Okay, so the formula for Hanning window, it is the formula w h of n equal to Hanning window, it is same 0.5 plus 0.5 cos of 2 pi n divided by n minus 1. Okay, for the values of n minus 1 minus of n minus 1 2 plus n minus 1 by 2. Okay, so here we have the samples, n is equal to 11. So the values will range from minus 5 to plus 5. So minus of 11 minus 1 divided by 2, 11 minus 1 by minus 5 to plus 5. Yeah, then find the values. WHN of 0 is equal to 0.5 plus cos of 2 pi n divided by n minus 1, it is 0, 10 into 0.5. So instead of pi, you have to substitute 180 here. Don't use 3.14 here. Pi, you have to substitute. If you solve with 3.14, you will get the wrong answer, since it is, we are using it cos degrees, so it is 180. So next, WH of n 1 is equal to WH of minus 1. Okay, HN of minus 1. Okay, since we are having minus 5 to plus 5, they are symmetric. Window, it is symmetric. Windowing, it will be symmetric. What is the value of 1? It will be the value of minus 1. What is the value of minus 2? Equal to the value of plus 2. Maybe the signs will vary. So they are equal. So minus 1 and plus 1 are equal. So 0.5 plus 0.5 cos of 2 pi, instead of n it is 1 divided by n minus 1. So on solving this, you will get the answer of 0.9045. WH of n is equal to 2. WH n minus 2 is equal to, solve 0.655. For Hanning window coefficient of 3, you get 0.345. So whatever values you are writing, you are calculating, please have at least 3 to 4 decimal numbers, so only you can get the answer nearer to the exact answer. Sometimes we may miss some points, so it is better to have the fractional terms or with at least 4 decimal places or 3 decimal places. Okay, so I have calculated for wh of 0 2, which is equal to 1 here, 1 2 3 4 5. Okay, so first okay, next it is you have to solve the filter coefficients. Okay, so what is the hd of n value here? Hd of n value, it is 1 by 2 pi jn sin pi n minus sin pi by 4 by n. So solve for the value. Hd of n is equal to 1 by 2 pi jn into sine of pi n minus sine pi by 4 into n. So since it is symmetrical one, we have seen symmetrical one, right? These are symmetrical ones. What is the value of pi by 4? It is the value of minus pi by 4. What is the value of pi? It is minus pi. So your filter coefficients are also symmetric. So we can say here the value of hd of 0 as something, I'll come there later. So hd of 1 equal to hd of minus 1. So hd of 2 is equal to hd of minus 2. Next, hd of 3, it is equal to hd of minus 3. So next, hd of 4 is equal to hd of minus 4. Next, hd of 5, hd of minus 5. So why I am taking why I am finishing with the 5 means we are having the values of n is equal to 11. So 11 values, hd of 0, and here 1 5, here 1 5, so 5 plus 5 10 and 11. So n is equal to 11. So we calculate for hd of 0. So instead of n it is 0, substitute wherever the n, 1 divided by 0 to 2 pi into n into sine of pi n. Instead of pi you substitute 180 degree into 0 minus sine pi by 4 into 0. Okay, so if you substitute here, what you will be obtaining is, you have to use here, and here it is sine of 0, sine 0, the value it is 0 divided by, here it is 0, 0 by 0 we can calculate, so we go for L'Hopital's rule. So it says limit of some n tends to 0 with the some theta tends to 0, sine theta divided by theta, you have the answer of 1. So here also same thing, so n tends to 0, and on the sign of something divided by 0, so you can have the answer here, it is 1. Don't forget this rule. Limit of theta tends to 0, sine theta divided by theta is equal to 1. You also have limit of some theta tends to 0, sine n theta divided by theta. So here another one value, n theta divided by theta, if it is multiplied by the y and variable n, you have the value of n. You can use both the values. Okay, so next you have to find hd of 1, so which is equal to 1 divided by 2 pi j, instead of n it is 1, into sine of, instead of pi you have to substitute, it is 180 degree, into n it is 1 minus sine pi, it is 180 divided by 4 into 1. Okay, so here you have to note on one thing, very important thing, that is here in this pi you have to substitute 180 degree, in denominator pi you have to substitute 3.14. okay, so the important thing is sine of pi n, we have to substitute 180, and divided by thing, here there is a pi, you have to use it in 3.14 instead of pi. So on solving this, you will get the hd of value, it is minus 0.225. So hd of 2, it is minus 0.159, and hd of 3, it is minus 0.075, and here it is 0 and HG of phi 0 0 4 5. If you see the values here, the values will be okay, the values will be little growing or decreasing like this. Okay, here there are minus value 0 and it is an increasing value, likewise it goes. Okay, then we have to find the filter coefficient. Okay, so filter coefficients, that can be calculated by h of n is equal to hd of n into omega of n for from minus n minus 1 by 2 to plus n minus 1 by 2. So that here it is minus by 2 plus 5. Okay, so while solving this, you have h of 1 or h of 0. H of 0 is equal to hd of 0 into omega of 0, and h of 1 is equal to hd of 1 into w of 1, and h of 2 is equal to hd of 2 into w of 2. So likewise, h of 3 is equal to hd of 3 into w of 3. H of 4 is equal to hd of 4 into w of 4. Like h of 5 is equal to hd of 5 into w of 5. Okay, so next hd of 0 we have found it is somewhere like 0.75 into 1. H of 1 it is minus 0.225 into w of 1 we have found it as 0.90 something. So once all multiplying minus 0.204 and multiplying these two values, you get the value of minus 0.104, and h of 3 value it is so multiplying these two values, it is 0 minus 0.026. These two values are 0. So at last we have to find the h of z. H of z, the formula it is h of 0 plus summation of n equal to 1 to n minus 1 by 2 h of n z power minus n plus z power plus n. So here the n minus 2 one value it is 5. So we can have it as h of 0 plus h of n values. So h of n, that is first value, n is equal to 1, h of n. So h of n the value it is 1, the value it is minus 0.204. So minus 0.204 into z power minus 1, z power plus 1. Next, h of 2. H of 2 value it is minus 0.104, z power minus 2 plus z power plus 2. Plus h of 3. H of 3 the value it is minus 0.026 into z power minus 3 plus z power plus 3, and h of 0, h of 4 and h of 5 are the values are 0. So this is the h of z transfer function value they have asked in our given question. Okay, the first thing you have to do, if they ask your question, so we have to draw the magnitude graph, and they have stated as for minus omega values. So whatever the on the left hand side, it will be the equivalent to the right hand side, that both are mirror images and symmetrical ones. Okay, so we have to find hd of n. Hd of n by using the formula 1 by 2 pi integration of minus pi to pi hd of e per j omega n into d omega. Okay, we have to solve like this. So solution and integration minus minus a to b e per zx. So e per zx divided by z with the x values from a to b. So you solve this. So on solving, you will get terms like this. So on rewriting these terms, it is equivalent to e power minus I theta plus e power plus or minus e power minus I theta plus I theta minus I theta. If it is plus I theta, it is cos theta. If it is minus I minus of e minus I theta sin theta. So with this equation you rewrite this once. This term it is sin pi n, and this term it is sin pi before n. Then they have asked for Hanning window. So Hanning window, the formulas here. So after solving this, you will get the Hanning values minus 1 and plus 1, 2 and 3 and 4, 5. Since the window it is symmetric, so symmetric window, so you are having minus 1 and plus 1 values the same. Okay, so here in this formula, so 0.5 plus 0.5 cos of 2 pi n divided by n minus 1. Here you have to substitute, instead of pi it is 180. This is very important. Sometimes you may substitute as 3.14. Don't substitute 3.14. Substitute cos of 2 pi. Instead of pi it is 180 divided by into n divided by 10. So find all those w values, and you have to find hd of n values. In solving hd of n also, if an equation that is with the term sine, if there is an pi in terms of sine or cos, you have to substitute. Here it is 180 degree. So if it is left alone, here the pi it is left alone in denominator, so you have to substitute here 3.14. You should not forget this. Okay, so on substituting here it is in one different term. You can obtain sine of pi by 4, it is 180 into 0, so 0 by 0 it is 0 by 0. Here again it is sine of pi by 4 into 0 divided by 0. So here you can say here it is an another term. So it is sine of n theta divided by theta. So sine theta n theta divided by theta, the term it is 1 by 4. So 1 by 4. So here 0 by 0 it is 1. 1 minus 1 by 4. You can get it as 0.75. Okay. So you use the L'Hopital's rule if a term arises of 0 by 0 or sine of n theta divided by theta. Okay. This L'Hopital rule should be kept in mind. Then you have to solve for hd of all these hd of n values up to 5. Why? It is up to n is equal to 11, so you find up to n values. Okay, so so the thing you have to keep in mind, it is you have to substitute 180 degree with for pi, those who are with sine or cos, and for pi's in left alone you should substitute 3.14. So if a case arises like this, sine of theta by theta with the substitution of n theta is equal to 0, it is 1. Limit of 0 by 0, if it is left with n, you can substitute it as n. Okay, so find the hd as values, and for finding the filter coefficient n, you should multiply hd of n with the omega n from minus n minus 1 by 2 to plus n minus 1 by 2. Okay, so h of 0, h of 1 and h of 2, all those values you multiply all those values here, and you will obtain the h values here. Okay, so h0, h1, h2, h3, h4, h5. Okay, so for, after that in question they have asked to find the h of as a transfer function. The function equation is h of 0 plus summation of n equal to 0 to n minus 1 by 2 h of n into e power z power minus n plus z power plus 1. Okay, h of 0 value have to substitute, it is 0.75. Okay, plus h of 1 value and z power plus 1 and minus 1, h of 2 value z power minus 2 and plus 2, h of 3 value z power minus 3 and z power plus 3, plus h of 4 value we have to substitute. So h of 4 value it is 0, and plus h of 5 value it also 0. So we are leaving these terms.